In this video, I want to show you how machine learning models can be fooled and what we can do about it. If we look at our components of a generic machine learning system, we have the following information flow. We have clean and create our dataset, train our model and test it. Everything is fine. But what if your data source has been compromised? And this is one of the most highly studied and effective attacks on a machine learning system. Data poisoning. As data plays such a crucial role in machine learning, even a small deviation in the data can make the system useless. The attacker uses this vulnerability and sensitivity of the machine learning systems and try to manipulate the data to be used for training. Now let's look into our Jupyter notebook and look at an example of a poisoning attack on the MNIST dataset. The MNIST dataset consists of handwritten digits. We want to compromise our dataset now. But first we need to load some libraries. As you can see here, we use the secure machine learning toolkit and first need to train our classifier. We only consider 2 digits in this tutorial, the 5 and the 9, because they look very similar to each other. And after everything is loaded, we can start with the training. We split our dataset in training, validation and test, and we load it and normalize it, and then we train our classifier. As we can see, our accuracy is very good. And this is the function for the poisoning attack. We can choose from different parameters. You can play around whatever you like in your own notebook. I will upload this later in the description. And this is actually the attack. This is called C attack poisoning SVM. This is because we have trained it on a support vector machine. Now we start the attack, and you can see now that the accuracy on the test set was 93%, but after the attack it is only 50%, which is very bad. So we know our attack was successful, and as you can see here, we have the labels flipped. This is actually a number 5, as we know. The network predicted this as a 9. We have fooled our model with wrong data. The best data poisoning solutions are prevention and detections. Through consistent monitoring, we can prevent the model from learning from compromised data. Okay, let's assume our model is okay and was not poisoned with bad data. But after training, there is still another kind of threat we must the model protect from. This is called adversarial examples. Here, the model gets new inputs of data that are compromised with noise, which leads to false predictions in the end. For example, a hacker can trick an image classification neural network into an incorrect prediction by adding adversarial noise. This can cause the neural network to misidentify the image with a degree of certainty. This is a serious problem, especially for scenarios like healthcare or autonomous driving. Here, lives can be at stake. In this video, I have shown you the common attacks against machine learning models. And in the next video, I will show you how I tested my own model with performing my own adversarial attack to find out if it's vulnerable or not. And I will show you how to make it more robust against adversarial examples in the next video. Bye bye!